Hello, this is Mohr's circle, a tension and compression example. Example 1. Let's see. Okay, so looking at this, on the vertical surface you have 80 megapascals in compression. Horizontal surface you have 50 megapascals in tension, and the shear is 25 megapascals. So compression 80, 25. Now you can see, looking at the vertical surface, it's trying to go down into the clockwise direction. So it's clockwise. There we go. That lines up with what we're looking at right now. So now to get the 2 points out of this. So with the vertical surface point, you have 80 megapascals, which is negative because it's compression, and a shear of 25, which is positive because it's clockwise. Horizontal surface, 50 megapascals, positive because it's tension, negative 25 because you can look here, it's the opposite direction. It's trying to move counterclockwise, which is considered negative. Okay, so now you can plot those 2 points. Here the blue is the vertical point. And it's time to calculate to find the center of the circle, which is this red dot here, and the radius of the circle. Now, the equations for that are right here. And plugging in the values for that, you will find in this example that the center is at negative 15. That means negative 15 in the compression. And then the radius of the circle is 70. Okay, so then you can actually draw the circles where sigma P1 and P2. P1's on the far right, P2 is on the far left. Principal shear is directly above the center. Theta P is from the vertical point towards sigma P1. Tau max is the same as the principal tau. That is because this is a tension and compression case. If this was compression and compression or tension and tension, this would not be the case, and maximum shear and principal shear would not be the same value. Okay, so time to calculate these values. Here you have the equation for your normal stresses, the principal stresses, and the principal shear, which, plugging in these values, you will find that sigma P1 is 55, P2 is negative 85, and principal tau is the same as the radius value, so it's 70, which comes out to okay. Now, theta P is from the vertical point to the P1, so that means that you're looking at this kind of case. So your equation here is actually going to solve for the complement of it. So you have to subtract 90 degrees minus alpha over 2, and that will give you theta P. In this example, that will calculate out to 79. Tau max is also 70. Let's see. Okay, where your angle should come out to 79 degrees, roughly. This rounds to nearest whole integer. And it's negative because it's going counterclockwise. It's going clockwise towards the negative, where counterclockwise is positive. And that's it. You have all of your values.